Hello everyone, welcome to the introductory session to ML. Here we will be learning on how to build models, what machine learning is actually, and how to use different algorithms based on different what do we say, like different situations, how we could use different algorithms to build different models. Prerequisites are you should have a PC or laptop and obviously mobile phone work here, and also basic knowledge of Python. If you don't have, don't worry, go through the links I will be providing or any YouTube link, any YouTube channel you like, and just learn the basics of Python. That will be enough. Also, you would be requiring Jupyter Notebook. Here I will be using Kaggle, and if you don't have a Jupyter Notebook, no problem. I will give this link to download Jupyter Notebook in your systems. Also, you have to have a knack for learning. And once again, let's see what Kaggle is, where I will be working on. So Kaggle is a platform where you can just contribute your machine learning models, compete in competitions, contribute data sets, discuss with your machine learning engineers, and it also have courses which includes machine learning, pandas, data visualization, and lots of amazing stuff here you could learn here. It's a great platform. So I would be using this platform for my notebooks. So let's start. So what is basically machine learning, also popularly known as ML? As the name suggests, when a machine learns by itself depending on some previously stored data in a dataset and uses a specific algorithm which we will build in the future, and it uses that and make predictions or classifications. That's basically simply machine learning. Also, when we use machine learning, we use algorithm, right? So the first and foremost algorithm, the basic one, is linear regression. So what do we mean by linear regression? As the name suggests, linear means a straight line, right? So suppose I'm telling you an example, like predicting house prices based upon number of bedrooms. So like it's not necessary in the real life that price of a house will be dependent solely upon the bedrooms, right? It will be based upon the area of the plot, the age of the house, average number of bedrooms, and much more features. Okay, keeping that aside, what is a linear regression? I've told you the a single line, but what's the single line? It's basically the distance between all these points to the lines, which we can calculate as d, and just sum this all over, find out the root mean square of them, and just take out the minimum. Like differentiation, right? Okay, here's how the line is calculated. So the line equation will be y equals to mx plus c. Also note that this is a two-dimensional space, so that's why we have a single slope here. So directly proceeding to the this like data set, example I've created for you, an example data set. The example is pretty same as the one I've the prediction of house prices. So yeah, so like uh, I have inserted the data. Like there are area, bedrooms, age of the house, and its respective prices. I've also intentionally included a null value just to introduce you to the topic of data cleaning. So let's just make a new notebook and proceed to our building model. Let's name this notebook linear regression. Linear regression. Okay, let's start our session. Let's increase the font. Yeah. Hmm. Okay. So as we see that NumPy and pandas are pre-imported here. I will also import linear model from sklearn. Learn import. What's sklearn? It's library where you can just find all the classification, prediction, documentation which you can just run upon. Let me take you to there. Learn. I will also provide this link here. You can just go through it. It has classification, regression, clustering, also model selection, which I will be using along with pre-processing in the future. So you can just go through it. So moving on, I will name my dataset as df and just read it. So pd dot read csv. Just copy the path from here. Copy it. Oh, sorry. Copy it. Paste here. Yes. Okay, cool. Now we have to data clean it, right? Because we have null value. So I think a median is a suitable thing for it because there are more number of threes. According to me, it's a median. You can choose according to you, which should be suitable for this data filling part. Also, I would be using floor function. That's why I'm importing math. So let's name this median of bedrooms to be float function. So a function of what? The median. Which median? The column bedrooms. So df dot bedrooms dot median. Let's print it out. Okay, 3. Now let's fill this value into that null. So df dot bedrooms should be equal to, like, this column should be equal to the bedrooms who has a null value. So we will fill this null value with this median of bedrooms. As simple as that. Print it out. Cool. Now we are completed with our data cleaning part. So we'll proceed to our building model, our model building part. So I will name my model as reg, and will create an object of the um, library linear model. So that's a linear regression. I will fit my object model with feature variables and target variables. So my feature variables are the variables on which the target variables is decided or determined, and my target variable is which is to be determined. So that's a price, and my feature variables are the rest of the one. So that's area, bedrooms, and age. My target is, remember, we have to first fill the feature ones. So price, and okay, we are ready with the model. Also, I have told you that I'm using a two-dimensional space here, but also we know that there are more number of features here, so it will be a four-dimensional space. So that's why we will have three slopes and an intercept. So let's check what are the slopes are. So it would be coefficient. Sorry. Okay. The coefficient of the first, which is area, is 137. Similarly, this is for bedrooms and this is for age. Intercept, which is C, that's 383724. Okay. Okay, now let's predict. Let's predict a value, like a price of the house whose area is around 2500 units with 4 bedrooms and 5 years of age. That's pretty new, right? So if we predict roughly, so it's a 2500, right? So it should be around this. Bedrooms, it should be greater than this. And age is 5, which is pretty young. So it should be around 6 lakhs. Seems we predicted right. So it's 5,88,625. So here we are done with linear regression. Proceeding to our next regression model, which is logistic. Okay, so what's logistic? It is basically a classification model. It classifies between 0 and 1, no or yes. Like, it's a binary classification, right? So that's all. So if we visualize using a graph, let's say the number of persons buying an insurance. So the person with a lesser age are less likely to buy insurance than a person with a higher age. So if we visualize this, the graph would be like this, right? So what's this? It's similar to a sigmoid function, and the sigmoid function is the formula is 1 by 1 plus e to the power of minus z. Now it's your task to look up on this. What's this? What's its exact implementation? That's on you. I will just make you go through the data sets and how to build those models. Remember that this is an introductory session, so I will just introduce you. The rest learning part is totally on you. And don't worry, I will provide the links. You can just go through it, you can learn through it. Okay. So here we have the data set. As I have said you, depending on the age, like the age of the person and whether they have bought the insurance or not. Also, I've pre-coded a model. Let me show this to you. Okay. Hmm. So also NumPy and Pandas is pre-imported. I have additionally imported matplotlib as my data visualization part. I've imported this, I've read this PDF, this CSV file and printed it, and it seems to have no null data, so data cleaning is not required. I've visualized this data using a scattered plot. Also imported train test plate, which I have told you to go through the sklearn documentation. It just basically divides the whole data set into training and testing part. That's all. I've also used logistic regression, as this is a logistic regression example, so I have to use it. Created the object and named the model as model, fitted the data, and the X test seems to be having 1, 2, 3, 4, 5, 6, 6 the 6 capacity data set, and it includes 55, 54, 27, and so on. So if we see, the 55% should be more likely to buy the insurance. Similarly, for 54, he or she should be more likely, and 27 should be less likely. Going through predict probab, which is the probability whether the person will buy or not. So here we can see the left column, like the left column gives me the probability whether the person will not buy the insurance, and for the right part, the he or she will buy. So as I have told, 55 is more likely to buy. Yes, 89%. Similarly, 54, 87%. 27 should be less likely to buy. So yeah, 89%. So it matches. Let's see the score, which is around 83%, which is pretty good. Okay, we are done with logistic regression. Moving on to decision trees. Okay, decision trees are used when there are lots of features to see upon, and it is very effective on decision making. Now, you would arise like there would be a doubt, like why not use logistic regressions on this, right? Like, let me introduce a data set to you. Decision trees, yeah. So here's a data set which says whether the salary is more than $100,000 or not, depending on the company a person is working on, the type of job, and the degree he has. So why not logistic regression? And in logistic regression, which I have explained before, I've used a two-dimensional space, and similarly here it also has a four-dimensional space. Like this doubt arises. But the thing is, like each and every feature is actually dependent on each other. So it makes a difficult task to segregate between them. Also, you can go through the documentation why we will use decision trees, and it's totally on you, like how to, like why it's used, and it's your task to dig up on it, dig in it. Let's go through the code. Okay. Hmm. So as NumPy and Pandas are pre-imported, I have used the dataset, read the dataset, the no null values, very good. Okay, I've dropped this because I need this as my target variable and set all the rest of these as inputs and just to the target. I have used label encoder here because see this thing is the object type and machine learning like computers work on numbers and not objects. So that's the main part of label encoder. Go through it. I will provide the link below. So I've converted the whole dataset into numbers and the target is in numbers. Imported tree, then made an object, fitted the data. Also the score is 1. But why 1? Because I have not splitted the data. The whole model is training on this whole data set. So that's why it's 100% accuracy. Okay, moving on to support vector machines. Okay, what's a support vector machine? If we look into it, a support vector machine, it's similar to decision trees, but not exactly. If there are a number of data sets here, similarly like this, we have multiple lines, right? So which line is best to segregate between them? The one which has maximum distance, right? So that's what uh, support vector machine is. It is useful when data is stored in higher dimensional space. That's where support vector machines come into picture. So let's visualize some data sets. Not data sets. I don't have any data set here, but I will show you my work. Uh, okay, support vector machine, right? Yeah. So I've imported pandas, and from sklearn dataset, I have imported load iris. Similarly, what I have showed you before the sklearn documentation, you just go through it. Also, in this iris dataset, yeah, see, here's where there are a number of data sets, right? And it is a multi-dimensional space. So here we would require a SVM, support vector machine. That's all. Okay. Mm, Now just go through it. I will not explain the whole thing into detail. It's your task. Learn. Okay. So we have the feature names like this, target names, say Setosa, Versicolor, and Virginica. All are dependent on each other, but it is a whole, like I've said that it is a multi-dimensional space. So it's a very like messy thing. So SVM is in our hands. It makes the whole task very simple. Also, don't worry, I will provide this notebook links so you could go through it again if you have any doubts. Like I have plotted a scatter plot here between petal length and petal width between setos and versicolor, and we can see a great amount of distance, a great amount of segregation. So here we can like there's a space for SVMs to be included. So this is a like visualization. So I have imported train test plate, which will just split the data into training and testing parts. Imported SVC, created that object, named that object as model, which will be our model. Fitted them, and our score is 1.0, like 100%. It's very wow. Okay, we have also predicted a data set which is 4.8, which is a sepal width, I think. Width? No, sepal length. So 4.8 centimeters sepal length, 3.0 centimeters sepal width, 1.5 centimeters petal length, and zero point 0.3 petal width. So it says 0, which is Setosa. Yeah. So moving on, we have Keyfold cross validation. So what is this thing? So Keyfold process not any algo, like any model building. It's just like when you're confused which model to use, you have this. Like if you're confused to use, um, if you want to use like decision trees or logistic regression or SVM, if you're confused, then use this. This will help you. So what it does basically, you have your data and it will split the whole data into k folds. What is k folds? Simply splits, k number of splits. That's all. And what's the use using splits? Sometimes the data is not uniform, right? So we use a stratified keyfold. Like this is a type of keyfold algorithm. There are more such. So I use most commonly stratified keyfold because it's easy to use. It segregates the whole data uniformly. That's all. What it does, it will iterate through all the splits, take one of them as test data set, and the rest of them as train data set, and just train them in a model and give the accuracy accuracy of I, if you want to visualize in a programming style, just iterate through it, and give the sum, and I think no, key splits. That's all. So sum of all accuracy divided by k, which is the average of all accuracies. That's all simple. So let's go to code. Let's see a sample code of Keyfold cross validation. So I've used logistic regression random forest classifier. By the way, what is a random forest classifier? This model actually grows multiple nodes or trees to classify a new data set on new attributes. Each tree or node gives a classification. Okay, and the model chooses the tree with the most votes on that particular classification. That's all. So now it's also completely your task to find on this, to dig in this. Okay, also I have also used the load digits dataset from sklearn. Again, I will provide this link. Go through it. It will be clear. Handwritten digits. Okay, these are the handwritten digits. I don't know why it's not coming here. I think my net. Okay, no problem. Just go through it. I will provide the link below. Also, I will provide my notebook links. So no need to worry. And if you don't get what are these syntaxes, no need to worry. Just go to YouTube and check out some videos from where you can learn. So I've imported the train test split the whole data set into train and testing parts. Also to make the things simple, I have used logistic regression, random forest, and SVM to segregate between all these and come out with the accuracy, and also will make you see what's the accuracy with k-fold cross. So that's a two-step verification, a two-side verification, not two-step. So with logistic regression, I have told you what's that. So it gives a 96% prediction. SVM, it's pretty bad. So we can say that SVM doesn't work for this model, for this data set. That's a 41%. Random forest, it's 96.85%. So it's good. Now we will look through upon Keyfold. Imported the Keyfold library and set the splits to 3, like there would be 3 parts of the whole data set. Splitted the whole thing into train and test splits. So there's 103, 102, like this. Now we will use the Keyfold So now I have declared a function which is get score, which will just fit the all the feature variables and training variables into this model and just return the score. That's all. As I've said, I usually use stratified keyfold, which is actually splits the whole data into uniform way. That's all, nothing big. Also, I've declared a list just to make you understand what it looks like. So this big code just returns the accuracy in each iteration. So first it's an 89, 95, 90, SVM it's bad, 38, 41, 51, and for random forest it's pretty good. So 92, 93, and 92. Now instead of this whole big code, we can do it in a single line, that's using cross-val score function. So import this, use this function, just write the name of which regression, like which algo you want to like come with. So in logistic regression, this is the result. With SVM, this is the result, and similarly for random forest. Also, you can use parameter tuning, but this comes in a much later stage, because once you are thorough with all these algorithms, you can do parameter tuning. And what's that? It's simply a trial and error method. There's no anything like any logic or any algorithm or any formula to do this. What it basically does, it just increases the accuracy, but it's totally trial and error method. That's all. So similarly, like I have done for random forest classifier, because we need to like set nodes or trees, as I've said. So how many nodes, how many trees? We don't know, right? So for 5, we are getting 87%. For 20, we are getting 93%. For 30, we are getting 94%. For 40, we are getting 95%. Remember, this is not like this, like the greater number of nodes, the greater number, like the greater accuracy we get. It's not such thing. Okay, it's totally random. So we are done with keyfold cross. Moving on, there's some other algorithms like random forest, which I have told you. K-means clustering, you have to search on it what it is. Naive based classifier algorithm. Okay, this last one is a very famous algorithm, and this algorithm is used in classifying emails, like what are spam and what are not. So it's like pretty interesting topic. So you have to work on it, and I will be providing all the links to the YouTube, all the YouTube links from where you can get the resources and all such thing, my notebook links. And I hope that you have liked this session, and also the links I have said that I will be providing in the description, and we will be coming with more interesting sessions ahead. And till then, keep learning. Thank you.